In the today's class, we shall study about the subtractor. So this is one of the application of the opamp. So you can see the diagram of the subtractor. Subtractor, what does it do? It amplifies the difference between the two input voltages and gives you the output. There are two inputs which it will be using, that is V1 and V2. So R1 and R2 are the resistor which is connected to it. Current which is flowing across it is I1 and I2. So IF is a current that is flowing across the feedback resistor. Coming into a subtractor here, I1 is equal to V1 minus of VA divided by R1. I2 is equal to V2 minus of VB divided by R2. IF is equal to VA minus of V out divided by R3. So here VA is equal to VB. You can just apply the values here, substitute it. So whatever the output you get is equal to minus V out of A plus V out of B. Substitute it. So you will end up with the when you substitute R1 is equal to R2, R3 is equal to R4, the V out is equal to R3 divided by R1 into V2 minus of V1. So R1 is equal to R2 is equal to R3 is equal to R4, that is equal to V out is equal to V2 minus of V1. Opamp as follower. So here you can see whatever the input you give, that will be the same, the output will be the same as input. So that is called as opamp as a voltage follower, the output voltage that follows the input voltage. So the circuit is named as a opamp voltage follower. The output is connected directly back to a negative inverting input, so the feedback is 100%. The V in is exactly equal to V out. If the V in increases, the V out is also increases. On other hand, if voltage V in decreases, V out will also decrease. It provides an effective isolation of the output from the signal source, that eliminating the load effect of single circuit from the first circuit. Because the input impedance of the opamp is very high, draws very low power from the signal source. Avoiding the load effects, the circuit is useful for the first stage. The property of the voltage follower. Voltage gain is equal to 1, input impedance Rin is equal to infinity, the output impedance Rout is equal to 0. The effective isolation of the output from the source signal source. So coming into opamp as a differentiator, it differentiates the input and gives you the output. That is a general definition. So let us discuss what it means. The differentiator produces an output voltage is proportional to the rate of change of input voltage V in. If the input is a sine wave, output of the differentiator is cosine wave. A differentiator with the only RC network is called as passive differentiator, whereas differentiator with opamp is called as active differentiator. The advantage of active differentiator have high output voltage and low output resistance than the passive RC differentiator. Advantages of opamp differentiator is an inverting amplifier which uses a capacitor in series with the input voltage V in, and the feedback resistor RF is connected between V output and an inverting input. The non-inverting input terminal of an opamp is connected to a ground. For DC input, the capacitor C behaves like an open circuit and also attenuates low frequency signal and allows only high frequency signal at the output. In other words, circuit behaves like a high pass filter. You can see in the diagram, sine wave input is given, the output what you are getting is a cosine wave. We are using a capacitor as well as the feedback resistor here. Opamp as a differentiator, let us discuss the related formula to it. When the inverting input terminal of the resistor of an opamp inverting circuit is replaced by a capacitor, the circuit worked as a differential circuit. Applying KCL at the node point G, Is minus In minus of I2 is equal to 0. In is equal to 0. Rn is equal to infinity. I2 is equal to Is. Since G is a virtual ground, the voltage across the capacitor Vc is equal to Q divided by C, that is equal to Vs. So Is is equal to dq by dt, that is equal to C dVs by dt. Q is equal to CVs. Again the output voltage VO is equal to minus I2 R2 is equal to minus Is R2. VO is equal to minus C R2 into dVs by dt. So coming into opamp as an integrator. So integrator that produces the output voltage is proportional to the integral of input Vin. If the input is a square wave, the output of the integrator will always be a triangle wave in the inverted wave, because we are giving the input to an inverting terminal. The integrator with the only RC is called as passive integrator, whereas the integrator with an opamp is called as active integrator. Advantages of an active integrator have high output voltage and low output resistance than the passive RC integrator. Opamp integrator is an inverting amplifier which uses a resistor Rin in series with the input voltage Vin and a capacitor C connected between Vout as shown in the figure. So for DC input, the capacitor C behaves like an open circuit and also attenuates the high frequency signal and allows only low frequency signal at the output. In other words, circuit behaves like a low pass filter. Coming into an opamp as an integrator, when the feedback resistor of an inverting circuit is replaced by an capacitor, the circuit is worked as an integrator. Output responds to a change in the input voltage over a time. Applying KCL at the node point G, Is minus of In minus of Ic is equal to 0. So G is a virtual ground, so Is is equal to Ic is equal to Vs by R1. Again the voltage across the capacitor Vc is equal to Q divided by C, that is equal to minus V0. But the capacitor charges, so Q is equal to integration of Is dt is equal to integration of Vs by R1 into dt. So output voltage V0 is equal to minus 1 divided by R1C integral of Vs dt. If the capacitor has some initial voltage Vx, Vo is equal to Vx minus of R1C integration of Vs dt. These are the few formulas of integrator, integrator, differentiator, summing, inverting and non-inverting. This is a summary of the formulas. You can just go through this formula. So AV is equal to V0 by Vi, that is equal to minus R2 by R1. Voltage gain AV is equal to V0 by V1 is equal to 1 plus R2 by R1. VO is equal to minus RF, that is given by V1 R1 plus V2 R2 plus V3 R3. Output voltage V0 is equal to R2 into C1 dV1 by dt. V0 is equal to minus 1 divided by R1 into C2 integration of V1 dt. Capacitor is equal to V0 is equal to Vc minus of 1 divided by R1 into C2 integration of V1. So by this we end this module. Thank you.